Okay, good morning to you guys. How did the homework go? Do you have any questions? Okay, you can put them up on chat while we give 1 minute for the rest of the students to join. Any questions about the homework? (7E). Which section, Isabel? Okay. All right, so we look at this question. So let me pick up the book. 2.6. Number 7E. Okay. Any other questions from anybody? Please put them on your chat while we look at this question. So, all right, number 7E, that's 7 and part E. Okay. All right. So we have the graph of a function. And the question is, if f of minus 1 equal f of 2 plus k, find the number k. All right, I'll give all of you a minute to do that. I think we did that before, but we do it again. So this is an equation, basically. They want you to find k. So to be able to find k, you have to be able to find f of minus 1 and f of 2. All right, so what is your answer? I give everybody a minute to get that. This is the graph. What do you think we should get for k? Anybody? Okay, please put your camera on to help me out. Please put your camera on. Okay, so what do you think k is? All right, so f of minus 1 is f of 2 plus k. So we look at the graph. What is f of minus 1? This is the graph of the function f. I just find f of minus 1. If this is minus 1, f of minus 1, I go up till I hit the graph. That should be a 4. So basically that's a 4. F of minus 2, f of 2, this is 2. F of 2, I go down till I hit the graph and figure out this value. This is minus 2 plus k. Another problem is to solve for k. So this will gonna give me, I add both to both sides, I will get 6 equal to k. Okay.
For the f of negative 1, doesn't it look more like on the screen? It looks like it goes to 3.
F of minus 1.
Yeah.
Let's see. It's 1, 2, 3. Oh yeah, you may be right. Sorry. 1, 2. Yeah. Thank you very much. Thanks. K equal to 5. My apology. Thank you. Any other questions? Okay. All right. So today we're gonna work number 15. Isabel, number 15 has a lot of pieces. I will not do all of them. You have to give me one particular problem. Okay. So we look at 15, part A. All right, and then we proceed. So number 15, part A. So here we have a function f of x equal 3x plus 5 And the question is, find a formula for f inverse of t. So let us remember how we do that. So we need the formula for f inverse of t. It means the question is, if we know the output t, we need a formula to give me the input in terms of the output. So here we need to find, basically we need to find the x such that f of x equal to t. So we want to find the x such that f of x equal to t. So we set 3x plus 5 equal to t and solve for x in terms of t. Okay. So we solve. So I need to isolate my x. It means 3x equal, I take away 5 from both sides. It means my x is t minus 5. I divide by 3 to get my x. So it means if I know my output, my input will be given by the formula t minus 5 divided by 3. That's the formula for f inverse of t. So graphically, it means I have the function f of x equal 3x plus 5. That's what we are trying to do. If we sketch this function, the graph here is a line. The intercept is at 5. That's really the graph. My question is, if I know the output, finding f inverse mean, okay, what is the input that gives me that? I know the t, what is the x that gives me this t? And this formula will give it to me. It tells me that's t minus 5 divided by 3. So if I know the output, if the output is 8, the input is going to be 8 minus 5 divided by 3, which is going to be 1. If the output is 10, the input will be 10 minus 5 divided by 3, and so on and so forth. Right? Any other questions before we proceed? Okay, thank you. So we're going to go back to quadratic equation, quadratic functions, and we hopefully finalize them today. So quadratic function. So remember last time we said a quadratic function. Today are functions that have very specific format. So they are functions of the form. So their form, it means the way they look. Okay, ax squared plus bx plus c. So this is how they look like, where my a is different from 0. Okay, those are the quadratic. Now we're talking about, last time when I left you, we talked about the graph of some basic one and then the graph of the general quadratic. So let me remind you, so graph of basic, I really call them basic quadratic. The most basic one, okay? So the most basic quadratic one is, and here I need a pencil, is f of x equal x squared. So that's the basic one. So f of x equal x squared, whose graph should be absolutely memory if you want. Okay. And we said last time, this is a parabola. The way we did that by just plugging point, so that's a parabola, so it's not a line anymore, is a U shape, it's a parabola, and it is concave up. So that's a parabola, concave up. So it's curving, it's concave up. And this point here, we will call it the vertex of the parabola. This is called the vertex, okay? And then we saw the other one. We took f of x equal minus x squared. So that's are the two ones we took. So f of x equal minus x squared And we realized that when I put minus x squared, we got the parabola, but going down. So that's the minus flipped the values. And this was concave down. So these are the two basic parabolas. So plus x squared is up, minus x squared down. And then when I did that last time, we also did the following. And let me see if you guys remember. I took another one. I took, okay, what if I take x squared and let us say added a constant 2. So I have a whole new function. I called it x squared plus 2. So how is the graph of this function in relation to the previous one? Anybody can tell me?
Wouldn't you shift the graph 2 spaces to the left?
Why to the left? Why?
Actually, no, wouldn't be up.
Exactly. You have to lift
Okay.
it up because
I was thinking of something else.
yeah. The other one is, I hope I can go through that at the end of the semester so you guys know that. The other one would be something like this. This will shift.
Okay.
All right, this one would shift, and I hope to do that at the end of the semester once I finish the one that I should, once I cover the program. I hope to spend some times at the end going over those carefully with you. All right, but this is the easy one. That's why I feel comfortable talking about it at this stage. Okay? So x squared plus 2 is just basically what this does. Whatever the previous one do, you're adding 2 to it. So if this is the origin, this is x squared. So if this is x squared down here, and what is x squared plus 2 do? X squared plus 2 is going to be, I'll do it in red. This is my 2. It's going to be a shift. It's an upward shift. It's shift upward by 2. And the reason is, suppose I take any value of x. Suppose I take the value 2. No, I'm not going to take 2 because I took 2 there. Suppose I take 4 here. Okay? If I take 4. X squared, that's the graph of x squared. That's x squared. This is going to be 4 squared. However, the g of x, what's going to take? It's going to take 4, but the output is going to be the same thing, but you're going to add 2 to it. So it's going to be 4 squared, but you're going to add this 2. So you're adding the 2 to the output. That's why we're shifting it up by 2. All right? So that's the easiest type of scenario of the shifting process. Now I can do shift down or shift up. What if I want this graph? If I want that. And in this case, that's the vertex. That's the vertex of the parabola. That's the vertex. Okay. Now, what if I do that? Suppose I take another function and I want it to have exact same graph as a parabola, like exactly like x squared, but something like this. I want that to be my graph. So exact same shape like the parabola, but I want to shift it down. What do you think h of x would be? Back to you guys. What do you think the formula will be for h of x? So it's the same parabola, it's x squared. This x squared. I'm going to take it down by 1. Shift everything down by 1. What do you think the formula is for h? Exactly, it's going to be x squared minus 1. X squared, because it's 1. Yeah, x squared minus 1. It means whatever x takes, for every x, this is x squared. This is going to take this one, but you take 1 away. So you're shifting it down. You're shifting it down. You're shifting it down. Okay, so these are the as I said, these are the simpler scenario. We will take other scenario, hopefully, at the end of the semester. Okay? Now, whatever I did here, I can do it for minus x squared. So this is minus x squared. I can also create another function. So I can do verbatim the same. So what I do here is actually so suppose I take a function which is something like that. Okay. This is the dotted one is minus x squared. The dotted one, this is the graph of minus x squared. And now let me call this 4. Okay. What's going to be the formula that gives me the red graph? So what is this? So I'm going to call this h of x. What do you think is going to be the formula for h? So basically, I took x4 and I shifted up. What do you think is going to be the formula for h? Okay, any idea? So this is minus x squared. I'm going to take it, shift it up. Every value, every output value is going to be shifted up by 4 units. Every output value is going to be shifted up. And so it's going to be minus x squared, but you're going to add 4 to it. Okay, that will be this graph in red. So it's minus x squared, and this will be my vertex. All right, so these are the most basic quadratic equation quadratic function that we should know their graph. I mean, these are the really, really basic one. And let us note that when the function is concave up, then it reaches a minimum at the vertex. When it is concave down, then its largest value is already obtained at the vertex. So it's going to give me the largest value of the function. Now, what about a general quadratic? I mean, this is very specific one. All of them, the b is 0. There is no coefficient of x. So in general, how the graph of a quadratic function looks like. So this is the basic one now in general. Okay. So graph of a quadratic function. And now I'm going to just dump the formulas on you. I apologize for that, but showing you where it comes from, it's going to confuse you more than anything else. So graph of any parabola, of a quadratic function, sorry, in general. Okay. So the graph will be, actually, we're going to have 2 different pictures, depending, because as you realize here, sometimes you have up and sometimes you have concave down and concave up. So what's going to really distinguish that? So my function is f of x equal ax squared plus bx plus c. The graph would be depending whether the coefficient of x squared is positive or it is negative. Now, if it is positive, the graph is going to be exactly like before. Exactly, it's going to be a parabola. It's going to be a parabola concave up, but the vertex is not going to be only shifted up. It's going to be also shifted this way, horizontally and vertically. So it's going to look something like that. Okay. And that's the vertex right here. And then I will tell you the coordinate of the vertex. So if A is positive, it's going to be concave up. Now, if K is negative, it's going to be concave down. And that's really the vertex right here of the parabola. Okay. Now the question is, that's where the formula I will not give you. What's the coordinate of the vertex? So this is the vertex, and that's the vertex. And the importance of the vertex is that's where the function reaches its minimum value. That's the smallest value the function takes, and this is take its largest value. So the coordinate of the vertex. So the x coordinate, that's the formula that you guys will have to memorize in a way. X coordinate of the vertex is minus b over 2a. So that's the x coordinate of the vertex. So this is my vertex right here. So the x coordinate, this is minus b over 2a. And so this is the vertex. This is minus b over 2a. So that's the x-coordinate. The y-coordinate is just the value of the function at this. So the y-coordinate of the vertex is the value that the function take at minus b over 2a. It means you plug in minus b into of 2a inside the formula and you get the y-coordinate. Right, so that's the shape, a positive versus a negative. That's the vertex, and these are the coordinates of the vertex. So let us a little bit practice this formula before we move on. Okay, so, and this is something you will memorize. As I said, telling you where it comes from is a little bit hard, so we skip over that. So let us see some examples. I'm going to give you a bunch of functions, and we're going to find the vertex, and we're going to sketch them very well. So examples. So the first simple example, actually they are all simple. I'm going to take the function f of x equal x squared plus 4x plus 5. Okay. The first question we want to ask is, simple question, find the coordinate of the vertex. So that's a typical quadratic. My a is 1, my b is 4, and my c is equal to 5. So that's a quadratic function. This is the a, the b, and the c. So find the coordinate of the vertex. And then we sketch it very well. All right. So what are the coordinates of the vertex? The x-coordinate is minus b over 2a. Okay. So minus b over 2a, it means minus 4 over 2. My a is 1, so it's going to be equal minus 2. So that's the coordinate. And then we're going to graph it and see everything on the graph. Now the y-coordinate. To find the y-coordinate, so that's the x-coordinate. The y-coordinate is the value of the function at minus 2, whatever the function takes at minus 2. So it's going to be equal minus 2 squared plus 4 times minus 2 plus 5. So which is going to be equal a 4 minus 8 plus 5, which would be equal minus 4 plus 5, which is going to be equal to 1. Okay. Now we're going to sketch the graph, and we're going to sketch it actually pretty decently in a way. So B is sketch the graph. All right. How? Let's sketch it. All right. Now, what do we know? A here is positive. A positive, it means that the graph, that's a quadratic, it's not a line, it's going to be a parabola, and a parabola going up, so concave up. Very good. Now, these are giving me, so the coordinate of the vertex, let me write them down here as a pair. So the vertex we have for coordinate minus 2 and 1. These are the coordinates. So to sketch it, I'm going to sketch the coordinates. These are the vertex. So this is minus 2 right here, and this is 1. This is my vertex. Okay, this is 1. So now I have a parabola, which is going up because A is positive, and that's my parabola. Perfect graph of a parabola. So I use this is my vertex as a guideline, and then it's positive, that's my parabola. Now, before I go on, whenever I have a parabola, one of the value I like to see is this value here. Okay, it means what's the value of f when x is equal to 0? So what's the value here? Just give me a good graph of my parabola. What's the value here? Back to you. If I ask you what's this value? or what's the y vertical intercept? What's the value here? How do you find it? Come on, let me put, I picked one of you who would like to answer. I'm looking for this value. How shall I find this value? Remember what we are graphing is this function. Means this function, if you graph it, you're gonna get this shape. I want this. What's that?
Can we plug it into the table?
Tell me what you mean. Plug what into the table?
I could be wrong, but it's the tables we made last time where you had the
Yeah, if you plug
X
it
and the
into the
Y.
table, we're gonna get something like that. But I want this particular value, this one here.
Okay.
If you plug in into the table, how do you get this value? If I plug in, so I'm gonna follow you. If I plug in, this value here will be obtained for which value of X?
0.
Right, don't be afraid of that. 0.
Yeah.
If X is 0, what is f of X? F of X? That's the formula for
Yeah.
it. So it's gonna be how much?
Wouldn't it just be 5?
It's gonna be exactly 5. So this value here is 5. So when you're sketching a parabola, to have a good picture of it, how it's gonna look like, is in those problems, because I'm telling you how the shape is, I'm telling you it's concave up, I'm finding the vertex. And so we know it looks like that, but it's nice to know when it's gonna hit the y-axis, when it's gonna intersect the vertical axis. So I have to find this. Okay, I have to find what's happening when x equal to 0, and the output is 5. So remember, this is x squared plus 4x plus 5. So basically, the 5 is giving me in this problem what happened when x is equal to 0. And now this is a very good graph of this function. Now suppose I ask you find the range of the function. So B is find the range of f. You guys remember this question? What's the range? Now that we had a very good graph, we can figure out the range. What's the range? Means what are all the output value? Back to you. So that's the graph of this function. What's the range now?
Would the range be from 1 to infinity?
Exactly. The range will be from 1 to infinity. This will be the range of the function. Okay. Now, simple question. What's the smallest value obtained by the function? Smallest value obtained by the function. Is this an easy or a hard question in here? It means what's the smallest value obtained by the function? Can we tell from the graph what's the smallest value? The question is simple. The question is simple. Don't make more out of it. So this is the graph. The function takes every possible value from 1 to infinity. So if I'm asking you what's the smallest value that the function take, it means the smallest value that the output take is equal to 1, because it's obtained right here at the vertex. And the vertex is -2, 1. So the smallest value of f is 1. That's the smallest value obtained by the function. The function reaches its smallest value at the vertex. So I'm going to give you another one and the same type of question, so you guys will be a little bit more comfortable with that. Okay. So my question is, So example number 2, along the same line, I have the following function, f of x equal minus 2x squared plus 4x plus 3. Okay, my question is, part A is find the coordinate of the vertex, so it means the x and y of the vertex, and graph carefully of the vertex and graph. Okay, and then, okay, I'll give you a minute to do it, or 2 minutes to do that. Please get going and then put your answers on chat. Of course, the answer for the vertex, put it on chat, and then we're gonna graph together. I will do it with you because I don't do the problems, I work them with you.
I got 1 for the x value.
Put it on chat, put it on chat.
Oh.
Yeah. Yep. Anybody else? I'm satisfied when I have a lot of students writing their answer. What's your y coordinate? Okay, still working on y. Very good. And then you guys graph it in front of you for yourself, and then I graph it myself and see if you guys are getting the graph correctly. On the graph, I want you to mark clearly when the graph intersect the vertical axis or the y-intercept. All right, I'm getting more answers. Okay, anybody else? Okay, somehow we're hovering between 1.5 and 1.11. So we have to clear this up. Is it 1.5 or 1.11? Okay, let's do it. So first, my A is -2, my B is 4, and my C equal to 3. So we first have to identify them. And then, so my x coordinate is -b over 2a. It's -4 over, now a is -2 over -4, which is going to give me the 1. So that's the x coordinate. Now for the y coordinate, I basically plug in 1. So for the y coordinate, I plug in 1 in the function. So at 1, I will have -2 plus 4 plus 3. So -2 plus 4 is going to give me a 2. 2 plus 3 is going to give me a 5. So the students are getting 11. Why we're getting 11? Why are we getting 11? Okay, so the coordinate of the vertex are 1 and 5. Okay, so this is the vertex. Now we have to graph the parabola. So this is a parabola shape that's quadratic. We have an x squared. We're going to have honest to goodness parabola. And this is the shape. First, we know that A is negative. It means there's going to be a parabola going down. So this is, okay. Now I know the vertex. The vertex is 1 and 5. That's my vertex. And this is a parabola going down. So this is going to look like this. I'm going to go like that and go down. And there is basically a symmetry in the graph. All right. So that's going to be the graph. Now, as I said before, I want you to mark clearly on the graph where the graph intersects the vertical axis. It means when the graph meets the y-axis. What's this value here? What is this value? And how do we get it? Please put them on chat. What's the value here? That's the graph of the function. So this is, if you pick up our calculator, we get exactly this graph. If we pick points and we sketch, we get this graph. That's really the idea. What's this value here? You guys are very reluctant in giving me this dot. Anybody would like to tell me what's this value here? Okay, if nobody's answering, it means you guys don't know. If this is the graph of the function, yeah, if this is the graph, it means this point is, if this point satisfies the equation, the formula for the function. Yeah, so if x is 0, that's here 0, this point should be f of 0. So what is f of 0? F of 0 is equal to 3. So let us note f of 0 is 0 plus 0 plus 3, it's equal to 3. It means this value here is 3. That's what really intersects. Okay. So now, for this function, what's the largest value obtained by this function? So now, when the graph is concave down, the function have a maximum value. So now, what's the maximum value obtained, or what's the maximum value obtained by the function? The function takes different value. It means the output take a lot of value. It takes the value 0, 1, 2, 3, minus 1. What's the maximum value obtained by the function? Okay, what's the maximum value? The maximum value is exactly 5. So that's the largest value the function obtained. No, my last problem with those ideas is the following. I'm not gonna ask, I'm gonna give you the following. Let f of x equal 2x squared plus 2x plus 3. Okay, and the question is, so example number 3. So this is my function. The question is, find the smallest value obtained by the function. Find the smallest value obtained by f. Okay, what's the smallest value so this is the function, you graph it. It's going to have a smallest value. What is the smallest value obtained by this function? Right, I give you 2 minutes to proceed. Please, all of you, do it. Okay, so in your mind, you can start imagining a little bit how this graph looks like, a parabola, a positive. So this is going to look something maybe like that, something like this. So it's going to have a smallest value. And that's really what I am after. All right, very good. That's the x coordinate. Now I want the y coordinate. Okay. You guys agree on -1/2. Anybody else got -1/2 for the x coordinate? Yep, okay, so let's find the x coordinate. At first, I identify my A, it's a 2. My B is a 2. And my C is a 3, okay? So the x coordinate is easy. The x coordinate is -b over 2a. It means -2 over 4 it means minus a half. All right, so the x coordinate is right. So already I know that's my parabola, that's my graph, and this is minus a half here. So I know that the vertex is, that's the x coordinate. I need to know the y coordinate. So I need the value of the function at minus a half. What did you guys get? I need the value of the function at minus a half. Anybody got a, so it's 2 times minus a half squared plus 2 times minus a half plus 3. Okay, and 5 halves. Okay, I hope I will check with you. Now, minus a half squared, it means minus a half times minus a half, which is going to give me that. 2 times minus a half is minus 1 plus 3. So I will get a half plus 2, common denominator, 5 halves. Okay. And now with this little bit of math, which is really not a lot, so it means that this is the vertex, this is the maximum. And now because a is positive, my function is going like this. So the smallest value, and then it goes up. So that's really my function. And this is here, that's the intercept. It means that's the value when x is 0. According to me here, x is 0 when x is 0, y equal to 3. It means this is value is a 3. And that's really the graph. So whether you take points and you plot, whether you pick up your calculator, or whether you do it the way we're doing it, which is good because now we actually know exactly where it's bottoming up, we're gonna get this for the graph of the function. So plug in point, you get that. Pick up your calculator, you get that. Whatever you do, that's the graph of the function. Yeah. So that's very good, actually. This is really helpful a lot for those quadratics. So we know exactly how they look like. Now, the second idea is the idea of the zeros of a function. So first I'm going to define definition, and then we're going to work with. The idea is, before I go, whenever we have a graph, point that we are in, whatever the function is, some point that we are interested in are usually where the function hits the x-axis. Those are points usually of interest. We're going to call those the zeros of f. So I'm going to introduce a new word. Suppose this is a function f of x. Those points here, where the graph hits the x-axis, it means where f of x equal to 0, they have a name, and they are called the zeros of the function. So that's the definition I'm going to introduce. So zeros of a function. So definition. Okay, so the zeros of a function, the zeros of a function are the values of x when f of x equal to 0. Okay, so they are the x value when f of x equal to 0. So graphically, the zeros are here. Whenever you have a function, suppose it's a parabola, it doesn't have to be. These are what we call the zeros of the function. Okay, so to find them, simple as that. So to find the zeros, we set f of x equal to 0 and solve for x. F of x equals 0 and solve for x. So let me take 2 examples to find the zeros. So for example, find the zeros of each of the following functions. Okay. So it's just a fancy word but the math is actually not hard. So find the zeros of a f of x equal x squared plus 4x minus 5. Okay, so find the zero of that. This is nothing more than, basically, as I said, we're going to set this is equal to 0 and solve for x. That's really what it is. Set this equal to 0 and solve for x. All right, now we've done this like a million times by now. So how do you solve for this here for 0 quickly, as far as we know so far?
Move 5 to the other side.
Uh-oh. Uh-oh.
Add 5 to the other side and get rid of it from the first side.
If I
Oh, no, we gotta make sure the 0 is up front. Or wait, no. Yeah, the first thing we do is the 5 thing, right?
the first thing is what?
We add 5 to both sides.
Okay, let us say I follow you. Usually when we do something, we do it for a reason. Okay, I will follow you. And then what do you want to do?
I don't know if we get rid of, I think we just get rid of the 4x, so we divide by, wait.
Wait, yes.
I'm not really sure to go from here.
Exactly, because this is not the right approach. Okay? Okay, but I want you to see it. So when we do something, we do it for you. You're absolutely right. You don't know where to go from there because there is nothing, I cannot isolate x. I have x squared, I have 4x. There is no way to isolate it. How do we do that? I want you guys to scream because we did this before. What's the word we should do in this particular problem? Remember, we should try to factor. Okay, we should try to factor this expression. So you put equal to 0 and we factor. Now, how can we factor this expression? Okay, it means can we find two numbers? When you multiply them, you get -5. And when you add them, you get a 4. So can we factor this expression? Yes or no? Come on, guys. I know you know that because I've done this a million times before. So what are the factors here? Five and 1. So this is 5 and 1, x plus 5 minus 1. So we definitely have to factor. And it's not 5 and 1, it should be -1 because when you multiply them, you get a -5. So we should have 5 and -1. So you look for two numbers. When you multiply them, you get -5. When you add them, you get a 4. So the numbers are going to be 5 and -1. And whenever you factor, you actually distribute to make sure you did it correctly. So usually when I factor, because sometimes I doubt myself, to check myself, I actually redistribute. So I say, okay, x times x, it's x squared minus x plus 5x. I'm just checking myself. I'm throwing -5. And this is x squared plus 4x minus 5. So it is correct. So I always try to check myself on this side. So whenever you have a quadratic and you're solving, one way we can solve is a factor. And then today the goal is to do something else if we cannot factor. So this will give me the two values is x equal -5 and x equal to 1. Those are the two zeros of the function. It means graphically, that's the picture. Graphically, that's the picture. That's my parabola. So that's my function. Plus 4x plus -5. That's my function. It's a graph, it's a parabola. We know that because that's a quadratic. This is the 0. It means that this function will intersect. So slowly, we're building more knowledge about this quadratic. And this is 1. So these are the points when the graph will intersect the x-axis. Now this is a parabola going up because the A is 1 here, which is positive. It means it's going up. So basically this parabola will be something like that. And in this stage of our learning, we actually even know what the vertex is. We have a formula for the vertex. So now I have a complete picture of the graph. And this is right here is what happened when x is 0. So it's going to be -5 as well. And this would be a graph of the function. All right. Example number 2, again, find the zeros of the following. B. This is not going to be quadratic, but it's not really hard. So suppose I have a function, means a rule, and this is the rule. Okay, for every x, it gives me this mass here. And the question is find the zeros. It means find the value of x such that f of x equal to 0. So it's the same question, find the zeros of f. So we're going to put the function equal to 0 and ask ourselves which value of x will give me 0. Okay, it means what should I put here? Which value of x, when I plug them in here, they spits out a 0. All right. What are the values of x which will give me a 0? Okay. Anybody? So even though if you're multiplying three factors, we can do it. What are the x's that give me 0 here? Anybody want to say anything? How can we find the values of x? Which x I should plug in here that will spit out a 0? Well, you're quiet. Okay, I'll pick one student. I'll pick on one of you. Okay, Xavier, are you with me? Xavier?
Yeah, I'm
okay,
with you.
give it your best shot. I don't care if you're right, you're wrong, it doesn't matter.
Would you only focus on the x minus 1 and the x plus 1? Would you only focus on those two and then not worry about the 2x plus 3?
Why? You want me? Why you're choosing the first two?
I don't know.
Okay, how can this product be 0? Every x that make the first term 0 will make the whole product 0. Am I right? So this is 0 if any x. So this means that, how can this be 0? If x minus 1 equal to 0, this value will make it 0. So if this times equal to 0, it means this will occur if this one is 0, or this one is 0, or this one is 0. So for this product to be 0, what does it mean? It means this term could be 0, and this will cause the whole thing equal to 0. X plus 1 equal to 0. X equal minus 1. So if I take x equal 1, the first term is 0. It means the whole thing will be 0. If I take x minus 1, this will be 0. It means the whole thing will be 0. And the last term is 0. So if this product is 0, it means, which give me 2x equal minus 3, means x equal minus 3/2. So there are 3 values that will make this expression 0. 1 will make it because if x is 1, the first factor is 0. Minus 1 will do it because if x is minus 1, the second factor is 0. It means the product is 0. Minus 3/2, this factor will be 0. It means the whole factor will be 0. In other words, If you have product of 3 terms equal to 0, to solve for that, you set each one of them equal to 0, and you find the x that will make this term equal to 0. So now graphically, it will reflect like this. This is a function. It is 0 at -1. It is 0 at 1. And it's 0 at -3/2. So basically, when you graph this function, it's going to hit the x-axis here. It's going to hit it back here. And then it's going to hit it back right there. It's going to look something like this. So the function will have 0 at 3 different values. So let me give you another one along those lines. So suppose f of x equal x plus 2. And I'm totally factoring it out to make it simple for us. X minus 1 and 2x plus 5. So fairly simple one. Again, find the zeros of f. It means which x values will make this expression 0. Okay, now please put your answer on chat this time because I hope this is easier for you. Okay. Which x's I should put here that spits out, make the expression 0. Okay, 5, and oh, sorry. Minus 2, 1, and minus 5 halves. Is it correct? If this product of 3 things are 0, this can occur. It means we set each one of them equal to 0 and we solve for x. That's 1, 0. I send the second factor equal to 0 and solve for x. The third factor to be 0 and solve for x. Every x here, every value here, if I plug it in for x, I will spit out the 0. The f will be equal to 0. So the zeros of a function are basically the values of x that makes the output 0. And on the graph, the zeros are, as I said, so in this case, that's a minus 2, minus 5 halves, and 1. It means the function will hit the x-axis at those 3 points. So it's going to be, that's just a rough sketch. It's going to be something like that. That's really how this function, particular function, looks like. This is not a quadratic, that's a cubic function. So it's not a parabola like before. It's a very different shape for the graph. All right. So when I took this function, f of x equal, let me go back to a function I took. You don't have to write this, but let me go back to this function, x squared plus 4x minus 5. Okay. And when I asked you to find the zeros, okay, and after a little bit of reminders, okay, we factored. So we factored this, 5, 1, x minus 1. And we say that the zeros, it means the value that make it are x equal 1 and x equal minus 5. Sometimes, and a lot of times actually, you don't know how to factor. You will not be able to factor it very easily. Okay, sometimes you cannot factor it very easily. And the question is, if we don't know how to factor, or we couldn't see how to factor, how we can solve this type of equation. Okay, so that's what we're going to talk about. And this is something I'm sure a lot of you has been hammered with, is how to solve this equation if we cannot factor, if we don't know really how to do it. So part 3 is, okay. So how to find the zeros of a quadratic functions, the zeros of a quadratic function, if we don't know how to factor. if we can't factor. Okay. Right. Right, so before to do that, I have to introduce the idea of a quadratic equation. Quadratic equation is an equation of the form. Equation, it means equality. Is an equation, that's the following equation. So quadratic equation is an equation of the form a x squared plus bx plus c equal to 0. The quadratic equation, equations means inequality between two things, is an equation of the following form. To solve this equation, we can factor if we can. If we cannot factor, the solutions of this equation are given by the following quadratic formula. I'm sure all of you have heard of that. The solutions, this means the value of x, are given by. Okay, quadratic formula. X equal. Oh, anybody remembers this formula? Anybody remember the formula? Okay. Minus b plus minus the square root of b squared minus 4ac divided by 2a. So if we cannot factor, we can use this formula to find the solution. In other words, there are two solutions, not only one. The first one is minus b plus the square root of that and the second is minus b minus the square root of that. So if we want to solve and we can't, we have to use what we call the quadratic, and this is called the quadratic formula. I'm sure a lot of you, most of you, have seen it back in high school. The quadratic formula. Okay. And the expression b squared minus 4ac usually is called, they give it a name, and it's called the discriminant. So I'll keep this here for a minute, and then we're going to practice this formula, quite a bit. So suppose you're solving a quadratic equation. If you can factor it, fine, we can factor and proceed, find the solution. But sometimes you can try, give it your best shot, you don't know how to factor it. You cannot factor it. I can't even easily. So in this case, to find the values of x that makes the expression 0, I have to use the quadratic formula. The quadratic formula tells me that we have two solutions. One is given by minus b, that's the b's, plus the square root of b squared minus 4ac over 2a, and one given by that formula. And the quantity, b squared minus 4ac, this has a name and it's called the discriminant. Okay, so let us practice this formula a little bit. So example. So example number 1. Let f of x equal to x squared plus 4x plus 3. So that's my function. Question is find the zeros of f, which is really mean find the zeros of x. Which barely means find the x value that makes the expression that makes f of x 0. Means for which x I should plug it in here. So I have the answer will be 0. So we're going to set 2x squared, that's my f, equal to 0, and solve for x. Okay. Now, and solve for x. So this expression is hard to factor. First, I have a 2 in here, and I have a 3. So if I want to factor it, it's going to be hard to factor. But still, there are x values that make it 0. There's something I can plug it here so that this expression is 0. So we're going to use the quadratic equation to do it. So to use the quadratic, first I need to identify the a, the b, and the c. And the question is, we're going to use the quadratic formula for it. All right. To use the quadratic formula, I need to evaluate. So I will write here the quadratic formula to remind you what it is. It's minus b plus or minus b squared minus 4ac times 2a. Okay, so that's the quadratic. So to use it, I have to evaluate b squared minus 4ac and then proceed. So let us take care of this term first and then the solution. So what's b squared minus 4ac? B squared is 16 minus 4 times 2 times 3. It means 16 minus sorry. My apology, put minus 3 here. My full apology, minus 3. Okay, put minus 3 for C. My apology for that. And this is gonna give me a minus in here. Minus gonna give me a plus. 4 times 2 is 8. 8 times 3 is gonna give me 24. So this would give me 16 plus 24. This gives me 0. This is equal to 40. Okay, so that's the b squared minus 4ac. So that we can, now let us apply the formula. We have two solutions. First solution and the second solution. What's the first solution? It's minus b, minus 4, plus the square root of b squared minus 4ac divided by 2 times a. 2 times a. So it's equal to that. So the first solution is minus 4 plus the square root of 40 divided by 4. Okay. So let us a little bit. Now we have the solution. We can plug this into a calculator and get an estimate how much it is. Or we can a little bit try to simplify that because it's a good algebra problem. So let's see how we can simplify it. It's equal to, let me see, square root of 40. Okay, I'm going to write it here to explain the algebra. Now 40 is 4 times 10. Am I right? Am I correct? I'm going to write wrong stuff to see if you guys are with me. Okay. This is equal to what? I can split this into the square root of 4 times the square root of 10. Now the square root of 4 is 2. I will get 2 times the square root of 10. So the square root of 40, I can a little bit simplify it into 2 square root of 10. So my goal now is to simplify this expression. So I will get minus 4 plus 2 square root of 10 divided by 4. Okay, so my goal here is basically to do a little bit of algebra to simplify this expression. Can I go a little bit further? What do you think? Can I improve on that? Can anybody think of a way to improve on this? Simplify it a little bit more. Peyton, are you with me? Peyton, are you with me? Yes or no? Okay. I'll pick another student. Sage, are you with me? No, I can't hear you, Peyton. No. No, I couldn't hear you. Okay, I'll move on. Fix it, and then I'll get back to you. Sage, are you with me? That's okay. Don't worry. Sage, how do you think I can improve a little bit? Anybody?
I think you're fine. Sorry, I was in the bathroom.
Okay.
So I just got back, so I'm trying to see what you did.
All right, Taylor, do you think you can help? Taylor M.
I don't think I can help.
All right, anybody? Nick, do you think you can improve on mine? Okay, he doesn't think we can simplify it any further. We can do a little bit. So watch what I'm going to do. Okay, one thing I can do is that, let's say 4 and that's it 2. I said, you know, I can somehow factor out a 2 in here. I can do a little bit of simplification. If I factor out the 2 here, this should remain minus 2 plus the square root of 10. I divide this by 4. So that's the best simplification, because if you guys look up the answer, your book is doing this for you. And now I simplify. This is a 2 and this is a 4. I will be left with minus 2 plus the square root of 10 divided by 2. And that's really the best we can do. That's the most simplification possible. So that's going to give me one solution. Now the other solution. So that's one. The other solution is minus 4 minus the square root of 40 divided by 2. So that's one solution. That's the most simplified possible. The other is minus 4 minus the square root of 40, which is going to be equal to minus 4. The square root of 40, I can proceed the same. It's the square root of 4 times 10. It's the square root of 4 times the square root of 10. This is going to give me 2 times the square root of 10 divided by 2. And then I would, divided by 4. And then I will do exactly like I did before. I'm going to factor out a 2, which will leave me with minus 2 minus the square root of 10 over 4, which would leave me with minus 2 minus the square root of 10 divided by 2. End of the problem. Okay, so now we have two solutions. So my two solutions are the first one is minus 2 plus the square root of 10 over 2. And my second one is minus 2 minus the square root of 10 over 2. And if we want the value, we can approximate it basically by using our calculator. So let me sum up, since I'm out, the time is off. So let me sum up. If you have a quadratic functions and you want to find the zeros, so you first start to factor. If you don't know how to factor, you could not factor it. To be able to find the zero, we have to use this quadratic formula, and this will give me the zero. So that's really how we approach factoring. So summary of this whole section, this whole chapter basically is the following. So we're going to a little bit spend 1 minute summarizing. So quadratic functions, they are functions of this form. That's the quadratic function. Their graph depends whether A is positive or A is negative. A positive, we get that. A negative is concave down. The coordinate of the vertex are given by this formula, minus B over 2A. The second question is we are interested in is the zeros of the quadratic function. It means when does it hit the x-axis? To find the value where f of x equal to 0, this is what we call 0, then we need to solve this quadratic equation. You try to factor it. If you can't, you have to use the quadratic formula. All right, so that's all about everything we have so far about quadratic function. It's right there. All right. Okay, I stop right here. Remember, you have a quiz, not remember, you have a quiz on Tuesday, and I will tell you what you are responsible for. So you have a quiz on Tuesday. And remember your online homework due tonight. Due tonight. Okay, and for Tuesday, please make sure you do all the practice problem I'm going to assign from this section.
Are we gonna have a new online